Hey ho, this is the lesson that I promised I would give you, which we figure out the formula, which is down the bottom right-hand corner here of the interval estimate or the confidence interval being given by this old thing here. And we're going to work out how to come up with this confidence interval here so that we can use it without knowing how to use it though. But I find that if students understand how it's constructed, they get a deeper understanding of how the confidence interval works, and therefore they're able to articulate what's going on in a lot better detail. So it's not necessary for you to know how the formula is worked out in order to pass the course, but for those who need and want a deeper understanding of how confidence intervals work, this is the video for you. And to make life easier, I'm just going to stick with a confidence interval of 90%, which we know gives us a Z value of 1.65, and we're going to work from that. So what does that Z value of 1.65 mean in terms of a confidence interval? If we sort of treat it like a probability distribution, just for the sake of understanding what we're doing here, we would say that with the Z value for a 90%, we would have a lower boundary of minus 1.65, and Z would be between that and positive 1.65 in a standard normal distribution, and the probability of that occurring is 0.9. That's how we would just naturally read that. We've also got related facts which have got to do with transforming from the original normal distribution to a standard normal distribution. We know that Z is equal to X minus the mean over sigma. We also know that the mean is given by the value P, and that the corresponding standard deviation sigma is given by P multiplied by 1 minus P all over N, and we take the square root of it for the standard deviation. Okay, so what we're going to simply do is we're going to come up with a new expression for Z, which effectively is the middle here, and that expression is going to be using the following values. Z is, well, X is going to be our value of our sample proportion, P hat. And then we're going to subtract mu, which is P, all over the square root of P outside of 1 minus P all over N, like so. So that means that the probability between those two values can now be written as, I need to squish it in a little bit, the probability, so I'm writing a little bit small, hope that's okay, is minus 1.65. Oops. And then instead of Z, I'm just going to write that big old expression, P hat minus P all over the square root of P multiplied by 1 minus P all over N is less than 1.65 is equal to 0.9. Okay, let's follow our nose a little bit. Now, I'm going to be doing a bit of inequality operations here, which have some side effect, which I'll express as I go along. But at least for this next bit, because I've actually got effectively two inequalities sandwiched between this value here, if I do an operation to this middle value, I simply need to apply the same operation to both of these here. Now, because I'm going to multiply this value here by the denominator to remove it. Okay, standard sort of equation solving, and therefore I multiply each of the endpoints by this as well. And I can do that and keep the inequalities facing in this direction because the square root of this value is going to be positive. So what do I do if I multiply through by the denominator? I get, again, I'm squishing it a little bit to make sure it fits in, minus 1.65 multiplied by P outside of 1 minus P all over N is less than the numerator, which is just P hat minus P, is less than 1.65 multiplied by P outside of 1 minus P all over N equals 0.9. Okay, so all I've done is multiplied through the whole expression here by the denominator. This is looking pretty good. Next step is, this is where I do a little bit of inequality work, which is, if I tried to explain it too much, it would take too much of the video. But effectively, I can now take P hat to either side here. That would leave me with a negative P, but I want a positive P in the middle. long story short, by removing the p hat and the minus from the middle there, I end up with the probability of p hat on the left here minus 1.65 square root p outside of 1 minus p all over n is less than, p is less than 1.65 square root of p 1 minus p all over n is equal to 0.9. Okay, so that gives us p in the middle of this kind of interval if p happened to be in the middle of our interval. Now, what does that mean? So if I draw it as an interval, then I've got a middle, the middle of it will be p hat, because that's what the sample estimate was based on. And on the left-hand side, the boundary will be p hat minus 1.65 times the square root of p multiplied by 1 minus p all over n. And on the boundary on the other side is p hat plus 1.65 multiplied by the square root of p minus, oops, keep on saying that, p outside of 1 minus all over n, 1 minus p all over n. So that's what our interval will be. We're hoping that p itself will be somewhere in here, in this interval, and these are our endpoints, which is what our interval estimate is going to be. But it's an interval estimate, and the interval estimate is based on us taking p, which we don't know. Remember, we don't know what p actually is, but we're taking p and we're estimating it to be the same as p hat. And so we put little hats on our p's here to say we are using the sample estimate in these points, because we are using the point estimates to approximate or to stand in for our population proportion, which we don't know. And so there is the lower boundary for this same expression, and there is the lower boundary for this. Okay, so rewind, watch again if it didn't make sense to you. Try and get your head around this, because I think if you take the time to go, wait, what, a whole bunch of times until it sinks in as making sense, then I strongly suspect that by the end of it, you'll have a really solid understanding of how confidence intervals work. If at the end of the day you can create a confidence interval, but you can't quite figure out how it works, but you can use the formula effectively, that doesn't make you a high understander of confidence intervals, but at least it does give you a basic understanding of confidence intervals, which is certainly progress that you should be proud of as it stands. So if you don't understand this video, don't worry, don't stress about it too much. But if you do understand it, then I think that would be a really good step in solidifying your complete understanding about how confidence intervals work.